Welcome, this is your 5-minute geography lesson. We're covering theme 3, element 2, plate boundaries. Take your seats, I'm Mr. S and I'll be your 5-minute teacher. Tectonic plates are slabs of rock on the outer layer of the planet, known as the crust. These plates are constantly moving, which creates hazards like volcanoes and earthquakes. Let's have a look at the 3 basic boundaries. The first one we're going to look at is destructive. Now, a destructive boundary is where we tend to find 2 of the different types of plates meeting. So in this case, we've got oceanic and continental coming together. At a destructive boundary, it's always going to be the denser plate, the heavier plate that sinks underneath the lighter one. An oceanic crust is always denser than continental. We discussed the reason for this last lesson, but as we've got water, which is applying additional pressure onto this plate, anything that's in the water, so like dead sea animals, it could be sand and silt, or any type of material, is going to get forced by the water to the bottom onto the crust, and it builds up very dense layers. So this then makes it more dense than the continental plate. For that reason, when the 2 plates meet, the denser plate, the oceanic plate, is going to sink underneath. We call this process subduction when the plate sinks. And the continental plate, being lighter, rides over the top. At the point where these 2 start to subduct, which is indicated by these red circles, we get an intense point of friction. The movement between these 2 plates is not smooth. Rock is not smooth. There will be imperfections, jarring, there'll be snags, and what that produces is intense buildup of energy. And as the 2 plates try to overcome the inertia, the pause that they've produced. And when that pressure builds up to the point where the plate jerks past one another, it releases that energy in the form of large outburst of seismic waves, so what we would call an earthquake. The oceanic plate is being forced into the mantle. So the mantle is incredibly hot, made up of molten rock, so it's going to melt this plate, which produces additional magma inside the mantle, and that's got to go somewhere. And what happens? There is imperfections, cracks, fissures in the plate. So in this case, it's on the continental side of the plate. And the magma, the additional magma, forces its way up through these imperfections until it reaches land. When magma reaches the surface, we call that lava, and it creates a volcano. So we get both earthquakes and volcanoes at destructive plate boundaries. The second one is a constructive boundary. And a constructive boundary is where we have 2 plates moving in opposing directions. And they tend to be the same type of plate. So you might have 2 oceanic or you might have 2 continental. As the 2 plates move away from each other, it creates a gap between the 2, which is indicated at A. And magma rises up between the 2 plates to fill that gap. So this actually creates new land because the magma is going to cool and stick to the sides of this plate, and as it keeps moving in opposite directions, creating new gaps, magma keeps rising up and forming new land on either side. So A is still a volcano. In this diagram, it's what we'd call a fissure volcano. It's just a gap between 2 plates, but you can get the more normal looking shaped volcanoes that look a bit like a cone or a mountain at this boundary as well. We don't find any earthquakes here because there's no friction between the 2 plates because they're moving in opposite directions. And then finally we have a conservative boundary. Now, whereas in destructive plates boundaries we're seeing land being destroyed, and in constructive plate boundaries land is being created, conservative boundaries don't have any plates being made or destroyed. That's why we call it a conservative. It's remaining the same. In this diagram you can see the plates are moving in opposing directions parallel to each other, so one's moving towards the southwest and one's moving towards the northeast. We see more in real life that actually move in the same or similar directions but at different rates of speed. So as these 2 plates are sliding past each other, again, like destructive, we're going to have some intense points of friction between the 2 plates as they try to roughly slide past each other. And that release of that energy as it builds up is called an earthquake. We've got some additional keywords that are used here to describe earthquakes. So where the earthquake actually happens, where the friction is built up underneath the surface, we call that the focus. That's where the energy is released. Where it actually happens on the land, so if we were to stand above where the earthquake actually started, that would be called the epicenter. And then you've got these yellow lines representing the energy being released, which are the seismic waves, which create the ground shaking, which destroy homes and create other sort of hazards. Now again, we're not going to find any volcanoes here because there's no plates being melted or there's no gaps between the plates to allow that magma to rise up. Well, that brings our lesson to an end, but continue at your own pace by completing the Now Try It task for homework. Class dismissed.